When exploring the topic of astrobiology, one of the hardest things to do, in fact probably the hardest, is to envision what intelligent biological alien life would actually look like. This is distinct from a technological intelligent alien. The appearance of a member of a post-biological machine civilization is utterly unpredictable and subject to change, as it would probably be able to download itself into whatever vehicles for its consciousness best suited its task, or alternatively, technological augmented biological aliens that can genetically alter themselves to be whatever biological form they wish, or even a mix of the two. But fully biological alien life can to a degree be vaguely envisioned because biology does have a few aspects, although not a lot of them, that are probably hard and fast rules wherever you go in the universe. This is mainly because evolution is in some way a natural form of chance engineering. With engineering, you aim to make something that works. With nature, that which simply doesn't work dies. Only success endures, and things change and then it doesn't. Nature also tends to settle on configurations that work best for their niches, or at least good enough if not ideal. Mutations that make no sense in a given environment are disfavored and tend to go away over time. This leads to a loose set of guidelines that are probably applicable everywhere in the universe for biology, and allows us to at least make a start in envisioning what it might look like, at least if it's carbon-based, such as we are, and we can glean some ideas based on envisioning different environments, but there are no guarantees of that, of course. But carbon remains the best element on the periodic table for the complex chemistry needed for life. This starts, of course, with simple life, which is the easiest to envision. Chances are there are microbes in this universe that are going to look a lot like our own. That is where life starts, simple organic chemistry on a microscopic scale. The supercar always comes after the horse and carriage, so to speak, and it probably more often than not occurs in water. Water is the universal solvent in the universe, and while other solvents are possible for abiogenesis to occur, they are either scarce or face significant issues that make the chemistry of life within them less likely than water. Other scenarios are possible, but organics and water are the best bet. So life starts simple, but as our planet shows, nature as an engineer tends to move towards complexity over time if it's possible for it to do so. But Earth may be different in this respect. This planet is clearly suited for progressive life that goes from simple to complex, but that may not happen everywhere. There may be places where life can't get complex. Indeed, this may be such a problem that it's possible that our planet is the only one in the observable universe to hold complex life, though that's probably very unlikely. Nature abhors a one-off, and there are almost always other examples. But simple life may be ubiquitous across the universe. There doesn't seem to be any reason why it wouldn't be. We seem to have a lot of options in this solar system for places where life can arise. Look at our ice shell moons. Any number of them might harbor liquid water, organics, and simple life. Places like Europa or Enceladus might shed insight here. But with recent discoveries within astrobiology, the chances of our universe teeming with microbes has risen. The first is the discovery that the production of RNA in nature isn't a big deal apparently, so long as you have percolation in volcanic basaltic glasses. Basaltic glasses like this are very common in the universe. You'll find them on Earth, the Moon, Mars, Venus, Io, and so on. Volcanic worlds very likely pervade the universe, as does organic chemistry in general, along with the conditions for liquid water. The conditions for the start of life, the RNA world, seem to be everywhere. The RNA world hypothesis does not represent an example of convergent evolution, rather the potential start of it. The RNA world hypothesis represents a period in Earth's history where RNA proliferated through self-replication, long before DNA and proteins appeared. And the case for this scenario leading to life on Earth is becoming increasingly accepted as evidence mounts, though there may have been other pathways. This may be a common way for the chemistry that leads to life to get started on exoplanets as well as Earth. But where it goes from there is still unknown. Through some process, DNA and life arises. But if that proves to be simple and straightforward, then our type of life at the microbial level could be extremely common in the universe. At that point, should it prove simple, then life itself must be everywhere and very similar. And it could very well be that we'll recognize alien microbes as such anywhere we might look as we explore the universe. But there are other markers for a convergence, and the next should be visible at a distance: photosynthesis. If alien microbes evolved the ability to photosynthesize, then it might be reasonable to expect to see the telltale disequilibrium of oxygen in exoplanet atmospheres. If you see a lot of oxygen with no ready explanation other than a biosphere, then you're looking at a planet that at least has simple photosynthesizing exoplants, and very likely an anaerobic predecessor, just like here on Earth. And that leads us to the possibility of complex life and the second recent discovery. One formerly strong candidate for a great filter is the prokaryotic to eukaryotic leap, but this has recently been weakened due to a link between it simply being a matter of a certain type of microbial symbiosis to occur, and the leap happens as a byproduct. In other words, like the formation of RNA, the answer turned out to be far simpler than previously imagined, if indeed that research holds. This opens the way for complex life on exoplanets to be common. But the options for life in those places going much past complex microbial life to actual animals may be more complicated. We just don't know. But if other filters lie within that question, then the universe itself consequently might be teeming with life, but it may be overwhelmingly microbial in nature and just can't get to serious complexity in most environments. But say it does get to complexity and eventually macrofauna, then what might it look like? Well, let's revisit the most basic forms of complex life on Earth, specifically the plants. Microbial development of life on Earth eventually allowed the plants and photosynthesis to arise. And the result wasn't good for most things living on the planet at the time. The increasing oxygen was deadly and forced the anaerobic life into specialized environments on Earth. But from there, the plants themselves were able to grow increasingly complex to the point of trees with leaves. It's not inconceivable that similar circumstances might lead to plant analogs very similar to our own, such as leaves to take advantage of light from their star, though the colors of those leaves are probably going to vary depending on the star's spectrum, and some have suggested that a more viable coloration for most trees in the universe may be black or purple. But that assumes that photosynthesis is common. It may not be. The great oxygenation event on Earth may or may not happen on alien worlds, at least not very often. Some worlds may never develop plants, or perhaps microbial evolution could go in an entirely different, unforeseen direction. But oxygen's reactivity proved useful in the development of even more complex life than the plants. Oxygen is energy. Indeed, look around. The animals breathe oxygen, and the plants breathe the carbon dioxide produced by the animals. This balance may be the only state of affairs in the universe that allows complex life to arise, and it may be common or extremely rare. We don't yet know. But in the end, this is largely just informed speculation based on life on Earth. We can only form vague ideas of alien plant life based on utility, yet the plants on Earth exhibit an enormous range, from algae to the cactus. But another question is, what is it about life forms on Earth that make them successful, and would it make them successful on an alien world? After all, small changes in the environment can cause extinction, and a reordering of even the plant life on Earth, such as that which caused the Carboniferous collapse, a mass extinction of plant life on Earth, or the effects of ocean acidification on algae. While we know stars exist and are an easy source of energy for life, we can go that far when speculating. Aliens may well have analogs of plants, but for even more complex life, the equation changes, and predicting what it might look like gets much more complicated. Look at animal biodiversity on this planet. It varies wildly according to adaptations specific to each animal, despite all of them having a common origin on the same planet. Even our closest cousins don't really look much like us. You are genetically very close to this animal, yet it may as well be an alien, as some have asserted over the years, and the equation broadens further when you look at the fossil record. This planet has produced an astonishing diversity in its animal kingdom, all on the same world, and on other planets it may be far wider than even Earth. It would seem an impossible task to try to predict what the entirely unrelated animal kingdoms of other worlds might look like, but it might be reasonable to expect analogs of certain types of Earth animals to exist, just like the plants, such as something like fish on water worlds, again because of the utility of the designs, but only vaguely. Fish aren't the only things living successfully in the oceans. As a result, shouldn't we also see things that are completely alien to our experience here on Earth? Very likely. There are probably life forms out there that we have little conception of, Because even with Earth's biodiversity, it has not produced all that is possible, probably not by a long shot. But we have one key feature here that does seem to put some additional restrictions on what alien life might look like. It's a good bet that any intelligent aliens are going to be highly complex organisms. Intelligence doesn't just come with simplicity, even with something intelligent but seemingly simple like a bird. Make no mistake, they are highly complex animals. Also, the environment intelligent life evolved in is going to impose some limits on how that intelligence developed and what direction it took. The first of which is the abundance of water. The smartest things in our ocean tend to be animals that once existed on land, and then evolved to go back into the ocean. Intelligent oceanic animals on their own, with no such land ancestry, tend not to be all that intelligent in comparison to the mammals. But that could also be a bias, and Earth cannot be used as a predictor of what can happen in an exoplanet's ocean, for which there may be less or no limits on intelligence development. Intelligence may arise simply because that's what conditions warrant, so natural selection goes that direction. But Earth might suggest that oceanic intelligence in general is slower to develop than land intelligence, perhaps everywhere in the universe. It might also suggest that oceans are easy environments for life, maybe too easy, because you simply don't need high intelligence to get by. A clam is just fine the way it is, and a bigger brain might not favor it, as it only needs to latch onto something, sit there, and filter. It does not need to do calculus, but an octopus eventually might find that useful. As a result, some oceanic animals have undergone little change for hundreds of millions of years simply because they have reached a successful design for what they do. A good example of this is the coelacanth, an ancient species of fish that first appeared about 400 million years ago, and was thought to have gone extinct about 66 million years ago until someone caught a live one in 1938. This fish is in more or less the same form it was when the dinosaurs were alive, and it's also probably about as intelligent as it ever was. So the point is, aquatic aliens on ocean planets may develop very, very slowly towards intelligence and possibly never reach it at all. And incidentally, people have tried to eat this fish, and from what I can tell, universally, they've said it tastes terrible. Perhaps tasting terrible or taking it next level to being outright poisonous might be something commonly seen on exoplanets because it favors survival very strongly. Though, as on Earth, what might be poisonous to one species is not to another. But it does show that one commonality we will see with biology is Darwinian evolution. There's simply no other way to go from a microbial world to one with macrofauna. Now, some might invoke intelligent design, but if that were the case, you'd think things would be designed better. After all, with our technology right now, we can and have made better microbes with streamlined genetics that remove the accumulated junk. And in macrofauna, while eating through the same apparatus that you breathe through works good enough for nature, it is not ideal and simply stems from chance. On other worlds, evolution may lead to a better state of affairs where the two processes are kept separate due to better circumstances than we had. This alone would lead to a massive expansion of biodiversity in the universe. For land-based aliens, just like it happened for us, the right conditions on exoplanets should be able to produce highly intelligent species, and a lot of it, in many different forms. You don't need to look like a human to have human-level intelligence, or better. Our planet has a multitude of very intelligent land creatures other than ourselves, and that intelligence is not limited to mammals. As I mentioned, some of the birds are incredibly intelligent for their size, and some even use tools. I find bird intelligence particularly interesting here, because unlike cats, dogs, and other familiar, intelligent mammals, birds are quite a bit further removed from us. Their history links back to the reptiles in a branch of the dinosaurs, so when you watch a crow use a stick to extract a larvae from a log, or even better, apparently seagulls have been shown to drop clams in front of cars on roads in order to crack them open. It might be closer to watching an alien perform a task than what you might get interacting with a mammalian pet, like a dog or a cat. Yet we can still recognize the utility and reasons the birds use their tools. Perhaps it would be the same with alien animal life. If you were watching an alien using tools, you could probably figure out what it was trying to do with those tools, especially if it's a deadly ray gun humming while it was being charged. But the more complicated the intelligence gets, the less this may apply in other areas. Watching an alien mating ritual, for example, may not be so immediately decipherable. any more than one can figure out the ins and outs of dolphin or elephant interactions, though the ultimate result is recognizable. We can know some, but much remains a mystery. Add technology to this and it gets much worse. Would an alien understand what a human was doing if it watched them play a video game? In truth, it may not even be able to interpret the television or computer screen. In short, land environments have their advantages as far as developing intelligence, largely because land environments are harsher places to live than oceans are, for the most part. Intelligence helps here, and with land evolution come more limits that are also probably similar anywhere you go in the universe. The first of these limits is bulk. The largest organisms on Earth have a very special feature. They all need something to support themselves. For the whales, this is water. For the giant fungi, it's living underground and being supported by the soil. For dinosaurs and elephants, enormous legs are required. That all comes at a cost. The largest land animals tend to lose agility to gain bulk, and eventually there is an upper limit to how big something can be, depending on its environment, and importantly, its gravity, which limits its weight, as does its ability to dissipate heat. A super-Earth a bit larger than Earth changes the weight equation, and eventually when you pass two Earth masses, exoplanets that large may absolutely prevent life, or at least complex life, just because of gravity. And there's also the question of heat. On Earth, you can get too large for efficient heat radiation. And while the gravity and temperatures of whatever exoplanet a species evolved on is going to affect that, in general, intelligent life is probably going to be loosely comparable in size to us and the other species here on Earth. But even on a slightly larger world, developing space travel may be impossible due to not being able to launch rockets out of a greater gravity well. While this thinking can be applied to advanced alien biological organisms as well, but again, it may not be the case for machine civilizations. There the possibilities change and they might be the size of a planet or bigger themselves, or even infinitely smaller. But intelligent biological aliens will probably not be giants, nor would they probably be microscopic. Neither would favor the utility that is necessary for intelligence. So it would be reasonable to expect that biological extraterrestrials would likely be roughly our size. I stress roughly. But other environments, such as an ocean planet or even a gas giant, could change the bulk equation. Carl Sagan once imagined giant gas bag animals floating in Jupiter-like atmospheres. But those atmospheres do not necessarily favor the rise of intelligence. So it may be a good bet to expect intelligent aliens to be on the same size spectrum as intelligent species on Earth. Another limit comes from what they would breathe. Here we run into chemical limits. While the case for simple life is different and more forgiving, there aren't a lot of gases a land-dwelling species can breathe that will support the chemistry needed to run a huge intelligent brain. Oxygen is best for this, so it's a good bet that most intelligent aliens will be no strangers to that gas, nor the life analogs that produce it. But what other gases they might use in addition to oxygen is anyone's guess. Atmospheric compositions of habitable exoplanets could and very likely do vary wildly, and if an alien comes from a world with a different atmospheric makeup, say a larger world with more hydrogen and higher atmospheric pressure, it's going to respirate very differently, and Earth's atmosphere might even be poisonous to it, probably likely so, presuming someone evolved not to use the high reactivity of oxygen in its chemistry. You don't see that one too much in sci-fi, where the aliens step off their spacecraft without environmental suits and immediately fall down hacking and coughing, before they ever get the chance to ask us to take them to our leader, before finally succumbing to some analog of the bends. But it's a wild card. Even if they prefer oxygen, they may not like some other atmospheric gas, or Earth's oxygen levels. Sad first contact scenarios aside, say they did land. What might they physically look like? Here we run into a trap. Over the decades, science fiction has attempted to paint pictures of aliens, but more often than not, it's not very realistically so. Take Star Trek, where the aliens were almost always humanoid in every way, except for green makeup or some forehead ridges. There was a practical reason for this. Early on, it was a whole lot easier to put some makeup on a person and create an alien than it was to build Jabba the Hutt puppets. But even in this age of advanced CGI, we still see lots of humanoid aliens, mainly because we can relate to them as characters much easier than we can something that looks like a xenomorph from Alien. It's hard to make something like that seem anything but a villain, because that's what it was designed to be. But there's a deeper problem. Out of millions of species present on this planet, we're currently the only true humanoids. In fact, throughout the history of life on Earth, other than a few species closely related to us, we're the only thing that can be vaguely called humanoid. Not many animals on this planet walk upright on 2 feet as a rule. Indeed, most of the mammals walk on 4 feet. That configuration of locomotion is far more common than bipedal. Are 4 legs more common in the universe than 2? No one knows for sure yet, but it may not be a good bet to make that everything walks on 2 legs. Instead, it's a better bet that natural selection on exoplanets is going to work fundamentally like it does on Earth, with wildly different environments that are going to produce species adapted for those environments. Those adaptations, along with dumb luck, and the evidence we see with the massive diversity of bioforms on Earth, are probably going to make for intelligent aliens very different from ourselves. They will not be flat-out primates as is all too often depicted, but they probably won't be that different either in the same way that an ant and a human differ. In other words, they should bear some very superficial resemblance. For example, appendages. Appendages are useful. You're going to need some form of them to build a civilization. Legs work pretty well, and plenty of species on Earth have them. Yet none have wheels, despite that being a more efficient way to get around, but only on perfectly flat ground. Legs get you much further on varying terrain. Arms and hands are good too for manipulating environments. So we can reasonably expect to see intelligent aliens that have something like arms and legs. Maybe, but how many? Most of the land mammals and us have 4, but this is accidental, a product of, again, dumb luck. All of these animals evolved from an ancestral group of fish that had 4 fins that could and did evolve into appendages. If you look at species that did not evolve from that ancestor, you find that the most common number in nature as far as appendages go is actually 6. Nature may favor that number for whatever reason. So it's possible that any alien life we find may be more likely to have 6 appendages rather than 4. And it's worth noting, our current Mars rovers have, take a guess, 6 wheels. There's a reason for that, and that it's better all-terrain design. So an intelligent alien may tend towards 6 legs. What would those appendages it has look like on an intelligent alien? There are some unlikely contenders. One of science fiction's go-to for aliens that aren't anthropomorphic are tentacles. Trouble is, mechanically, tentacles aren't very good unless you're in a very specific environment, such as an octopus pulling itself along the ocean floor. Outside that, the muscle structure of a tentacle isn't really something that's as good at building a civilization as something with bone structure and opposable thumbs is. Hands and bones or something like them might be more common than tentacles, at least with intelligent species. There are other useful things that intelligent human analog aliens might have, such as the senses. Eyes are great things if you have lots of light available, and on Earth, eyes have evolved independently at least 6 times. And there are other instances of this. Giving birth to live young has happened a number of separate times as well, and even photosynthesis seems to have happened 31 independent times on Earth. Flight, on the other hand, has developed 4 times on Earth. This includes the birds branching from the dinosaurs starting about 150 million years ago, but there were also the pterosaurs about 220 million years ago, and the insects were doing it 350 million years ago, and finally bats at 50 million years ago. You could also toss in humans if you want to count technological flight, despite us never naturally evolving the ability. And it continues with the senses. Touch, hearing, taste, smell, if the environment permits, all have proven useful, and aliens may have something like them, or entirely different senses not present on Earth. And things like eyes might even be located in similar places. It also makes sense to position sensory organs high up on the body. You can see better from your head rather than from your feet, meaning an extraterrestrial may have some type of head, or something resembling one, with the senses centralized around a brain. But these are not hard and fast rules. Sometimes evolution, despite favoring optimal configurations, might not result in what's actually optimal, but rather whatever works. A snail might be better off if it could run, but the circumstances weren't present to favor it to evolve that ability. I know, all of this is very vague. In truth, we can only speculate about aspects that might guide the evolution of alien life, rather than what it actually looks like. That's really the best we can do until we actually see alien life. This may never happen, and if it does, I suspect all of this will get blown out of the water, and they'll turn out to be nothing like what we, as biased Earthlings, can currently envision. So different, in fact, we might not even recognize them as alive. One thing that can be said for certain, however, is that nature loves to throw curveballs. So tell me your ideas on what you think an intelligent alien life form would look like in the comments below. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently wondering if Earth's oxygen atmosphere might actually be really nice for the aliens. More oxygen means more energy. They might just land and start doing dance moves, and first contact ends up as just a huge 2- and 6-legged dance party, and then they leave. That would be kind of awesome, and perhaps the best way first contact could unfold. Looking forward to showing off my moves. That could be bad. On that note, be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.